Okay, in this next video I'm going to explain what unbiasedness means for test statistics. So first of all, what is a test statistic or an estimator? Well, we looked at the population and a sample of a population, and what a test statistic does, it says something about the population. So it uses information from the sample and then uses it to say something about the populations. Maybe the mean, the variance. Well, in this case, we are going to look if an estimator is unbiased. And what does that mean? Well, we talked about the expectation of a random variable. Well, if the expectation of an estimator is the same as the parameter of the population, then it's unbiased. So, let's just take the mean. If the expectation of the sample mean, in this case, of the sample mean, denoted by this, is equal to the mean, so is equal to the mean, then it's unbiased. And we can show this, it's not too hard. So let's try. Okay, so the formula for the sample mean is y equals 1 divided by n. Like this. So this is the formula for the sample mean. And in this case we are going to try to prove if the expectation of this is the same as the mean. Well, okay, let's start by taking the expectation of this. This is always how we start, and then just filling it in. So we will get expected value like this. Okay, well, we know that 1 divided by n is just a constant, and a constant we can get out of the expectation. Then we would get this. And now the next step is to use what we saw previously, that the expected value, okay, I will get another color. Okay, so we use a rule, and that is use the rule that with expectations, the expectation of x plus y is the same as the expectation of x plus the expectation of y. So we can always split it. It doesn't matter if x and y are independent, this is always true. Okay, so we are going to use that because here it's just y1 plus y2 plus y3, and then we can split those. So we'll get 1 divided by n, and then this. So we will get the summation sign outside of the expectation. And the next step, this is like this, and the next step is to use the definition of the expectation, and the definition is that the expected value, so I will write it down again, the expected value of yi is the same as its mean, population mean, for all y. For all I. Then, okay, we're going to use it. So now we can write it like this. So the summation of mu y. And the next step is knowing that a summation of just a constant is every time the same constant. I can write it out. So I will get 1 divided by n, mu y, plus until we get n times. So you can also rewrite this as 1 divided by n times mu y. And now notice that the n's cancel out and we just get mu y. So in this case, it's mu y, the expected value of the mean is unbiased. Then continuing. Now we're going to do a little bit more difficult example. Write it down. So in this case, we're just going to show that the conditional write it down. So this is our test statistic, B tilde 1, and this is our test statistic. And now we want to show that this test statistic is unbiased, conditionally unbiased. And we are also given another fact, and that is that y, okay, let's write it down here. Okay, so yi, this y, is b1x plus ui. Okay, so yi is b1xi plus ui. And this is in later chapters, you will see what this actually means. But in this case, just use the formula. Okay? Then, continue. We want to find the expected value of this and show that it is just b1. Then it is, if this expected value is b1, then it's unbiased. Okay, let's start. So we always start by taking the expected value of this thing. Expected value. But in this case, it's given that x is given. So make a condition on x, because x1 until xn is already given. But what does this mean? Well, if it's given, we can just get it out of the expectation because we know what the value is. And that's very handy, because in that case, we can get rid of this summation. Note that splitting this is a little bit more difficult. We will get to that in the next step, but the first step is get this out of the expectation. All right, so let's do it. So get it out of the expectation, and then we will get this. Okay, so now that we got this, the next step is use this formula for this y. And let's make clear that this is yi. So we're going to use this formula and fill it in here. Okay, so now we're going to fill in the y. And we'll get this. Okay, the next step is, of course, get rid of those brackets, make it a lot easier. I'm going to get rid of what's here and continue on top. Okay, so from here, let's continue here. So get rid of the brackets. Okay, so first xi times bi xi will get x to the power 3 and then times b1, like this. Okay, next one is xi squared times ui. And we'll get this. And note again that the x are all given. Alright. Okay. Oh, forgot brackets here. The next step is splitting the summation. So we can split the summation into two summations. And we will get this result. Now, again, use the fact that x1 to xn is given, and we can get rid of this part, because we know all the x's, so we can just get out of the expectation. Then we will get first this again, then big bracket. This expectation will just be this value, because all what's in the expectation is given. So we will get summation this, and then we will just remain with the expected value of this term. Okay, now I'm going to clean it again. Let's continue. Here. Okay. Now we are interested in, I missed one bracket. Now we are interested in this part. So again, the x's are given, right? And well, a summation, as we saw before, a summation of all y's, we can just split the summation out of the expectation. With expected value of x plus y, we can just make expected value of x plus the expected value of y. And we are doing the same here. We can get rid of this part and get it out of the expectation. This part out of the expectation, so we will get summation to n. And we will remain with this. And if you don't know already, if you look in the further chapters, we know that by definition, the expected value of the error term given x1 until xn is 0. So this whole part will cancel out and we'll just get this part. And that is the summation 1 to n xi to the power 3. Bi can get out of the summation because it's just a constant. So you will get b1. And we will remain with this term. As you can see, this will cancel out, and eventually we will keep b1. Thus, it's conditionally unbiased.